cargo craft as it's grappled and docked to the International Space Station. That vehicle now will be unloaded over the next couple of days and weeks by the crew, but that was a subject of this weekend's activity. A lot of different milestones achieved after the launch just over a week ago. Joining me here on console is Quincy Harp, who is the mission designer for the HTV activities. Thanks for joining us, Quincy.
Thanks for having me here.
So first of all, I think this is the first time I've heard of a mission designer. It sounds very glamorous. Can you explain to us just a little bit about what that job entails?
Sure thing. Well, in robotics, we've kind of got two kind of positions. We've got our lead robotics officer, and his primary job is to integrate with the rest of the team. And for this mission, his name's John Bellingham. He's actually Canadian, and he works with us through this Canadian Space Agency. And my job is the mission designer. And in that position, we basically look at the requirements of where hardware comes up or where entire vehicles come up and where they need to be installed, and we design the path in between those two spots.
And you were explaining to me this process started at least a year ago, that the two of you were working together on this?
Missions typically start being planned about a year ahead. I was not assigned to this one until about 8 months ago, but typically there's about a year-long process with looking at the information and getting ready to go and going from there.
So you hit the ground running?
Very quickly, very quickly.
And how big of a team does it take to support these types of activities?
It varies from time to time. Typically you'll have about a 3-person team that follows the entire mission the whole way through, but when it comes down to the actual execution, you have largely as many people as you need, whether it's the 3 people that are on console actually executing or the next 3 people that are coming on after that team.
So bring us up to speed. A lot's gone on. Everything's gone really smoothly, but can you talk to us a little bit about especially the things that occurred over the weekend?
Sure thing. It's been a great last weekend so far. We actually captured the vehicle on Friday. The crew used the Space Station Robotic Arm, or Canadarm2, to capture the vehicle, and then, from that point on, the ground took control of it in order to help save the crew time, give them their time back, and we were able to maneuver the HTV vehicle all the way to its install location and install it, thereby giving the crew back all the time that they needed. After that was completed, we had kind of one day off before we came back on yesterday, Sunday, and then continued on with a lot of our ground-commanded activities to extract the exposed pallet from the HTV. And it's coming up carrying a couple different experiments for us, as well as a couple different replacement pieces of hardware for the space station. We extracted that. Then we maneuvered it to position, handed off to the Japanese robotic arm, which they also controlled from the ground. And from that point, they took it and installed it on their back porch, kind of their exposed facility is what it's actually called. And once it was there, it's ready for its transfers now.
So this was a lot of teamwork with the crew, a lot of things that you guys were taking versus parts that they were picking up and operating from the space station. So it really exemplifies kind of the ultimate teamwork, if you will, ground control teams and on-orbit crew members.
Oh, absolutely, and very international too. We've got U.S. and European crew members on orbit executing steps, as well as both Canadian and American robotics experts executing their steps, and Japanese experts executing their steps. So it's truly showing the International Space Station.
So everything that happened starting Friday and over the weekend sounds really critical, but you were telling me that really you guys have some of your biggest milestones are yet to come.
Absolutely. A lot of the dynamic parts happened on Friday, but when it comes to a lot of the down and dirty kind of ground control work, a lot of that's coming up in about 2 weeks, where we're going to use, again, Canadarm2, along with Dexter, the small dexterous robot that we have, to transfer those pieces of hardware that came up on that exposed pallet and get those to their final locations on the space station. That's going to take about 6 days of ground control operations, but we're looking forward to that. It's a significant amount of work to do, but we expect it to go well.
So I'm curious, which of all these activities is the most challenging?
Typically, the capture and the release of HTV itself is the most challenging, just because you've got 2 vehicles flying in space at extreme amounts of speed, and they've got to come together. You've got a lot of integration that has to go on with the entire team to make sure that those things turn out well. While robotically those are complex, probably the most complex for us is those upcoming operations we have in about 2 weeks.
And that's just because there's so much to happen.
Exactly.
So you said 6 days worth.
That's
pretty
what we
full
think.
Days.
Yeah, we're expecting pretty full days, 6 solid days of those operations to get all those things going. And it's pretty small interfaces that you're operating from the ground here up to a robot in space. So it's a cool factor to the job, but it is a complication.
Yeah, I think sometimes we make things look so easy because they go well, but so much time and effort goes into that pre-planning. Can you tell us a little, you mentioned the two vehicles traveling and those dynamic operations. Can you maybe explain for some folks who can't really appreciate how challenging that might be, what really goes into that, and when do you guys really get to breathe a sigh of relief?
Oh, yeah. Um, from the overall perspective, it's definitely a significant rendezvous problem. If nothing else, to put these two vehicles in the same space is amazing. And I don't know rendezvous very well, but I've heard it described as trying to stand in the backyard and throw a tennis ball while somebody in the front yard tries to throw a tennis ball and make them touch just slightly on the way across. So that's always very complicated. As well as doing the constant robotics that we're doing. We've built a lot of good techniques over the years with a lot of the ground control and everything else to make things better, but it still is very complicated. But in the end, we really aren't comfortable until we finally get to that final release day on HTV and we see the vehicle departing and everything's completed well. At that point, then we'll be able to relax a little bit.
Well, we hope that everything continues to go well. And while we have you, can you just tell us a little bit about your background and what led you to this position that you have now?
Oh, it's a bit of a long story, but I'll shorten it up. I lived in the area in high school and always kind of wanted to work at NASA, so I started in some early student programs, an actual high school program, and I transitioned that into what's called a co-op program when I was in college, and even transitioned into graduate co-op. So I got a lot of time to see a lot of the things going on at Johnson Space Center, and ended up liking working in robotics and robotics flight control, and have been doing that job for the most part ever since. Did a brief stint in a Russian support group, so I spent some time in Moscow. But otherwise, it's been great being in robotics.
Well, again, congratulations on all the activities this weekend, and we will all continue to watch and look forward to the upcoming activities and hope that we can have that same relief with you whenever the release happens and all that goes well. So thanks so much for joining us.
Thank you.
Again, Quincy Harp, the mission designer, as it were, for the current HTV activities going on board the International Space Station. Station Flight Control Room. All the activities going well, and as we've mentioned, the focus has been continuing to be on the HTV operations, which continued throughout the weekend, that actually resulting in the off day for the crew members. But it was done in large part due to a lot of different teams here on the ground team. Joining us here is Megan Levins, who is one of the robotics officers, but specifically the lead for Robot. Thanks for joining us. Why don't you start by, can you explain to us what Robot is?
Robot is our robotics onboard trainer. It's what our astronauts use in order to prepare for big robotic missions like HTV-4. So they use it as, it's kind of a simulation of what they'll actually be doing on the real day so they can practice in advance.
And this is a tool that they use from when they're assigned for the mission as well as on orbit?
Yes, it's the same simulation they use on the ground, so they spend all their time on the ground preparing for, like, say, HTV-4 or a SpaceX mission or an EVA using this same software, so when they get on board they can use what they're very used to and familiar to them and is of a high quality nature to prepare on board.
Can you tell us a little bit about the training curriculum for Robot and robotics in general? How does that, once an individual is selected as an astronaut, is that part of their astronaut candidate training? Is there a more advanced skill or training that only occurs once they're assigned to a mission?
They do a general training before they're assigned to a mission, that they get qualified to use the robotic manipulator, the Canadarm2. And then once they are assigned, they use simulations like Robot to prepare specifically for the mission that they have assigned. So our crews that are on board now used the sim to prepare for HTV-4. Once they got on orbit about 2 weeks out, since it may have been a long time since they've been on the ground, they used Robot as well as the Canadarm2 to prepare, kind of refresh their skills, remind them of what's really involved with HTV-4 so that they're very prepared when the time comes.
And some of our viewers may have heard about DUG in the past, which is also another term that's frequently used when robotics comes up. Can you explain to us the distinction between DUG and Robot?
DUG and Robot are similar. DUG is used more for situational awareness. It's more of a graphic tool. It shows the crew members the space station. They can put the Canadarm2, an EVA crew member, the HTV in places where they expect it to be and see what that looks like. Robot is a little more in depth in that it actually simulates the entire robotics workstation. So they have hand controllers to actually fly the Canadarm2 around, go in for the capture, press that trigger to get the good capture, and then do, whatever other operations they may have coming up.
How much proficiency training does a crew member usually need to prepare for these types of dynamic activities that we just had?
Well, in cases like HTV-4, our nominal plan, they do about 3 robot sessions and then 2 sessions with Canadarm2 where they actually go over and grapple, or at least go over the pin of a real grapple fixture flying from the cupola workstation itself.
And how long is the session?
About an hour, depending on the session. We'll do anything from watching the HTV approach so they can refresh on their HTV-specific telemetry, and then we'll go through and actually fly the robotic manipulator a couple times so they can get refamiliarize themselves with that operation as well. So anywhere from an hour to an hour and a half.
So Robot recently underwent some upgrades. Can you talk to us a little bit about that?
Yes. As you can imagine, something that's so graphic intensive like Robot, it does take a really long time for the simulation to even start, which is basically a person standing there watching a computer boot, which is not quite entertaining. Now, what we start with HTV-4 is we can actually do that part of the operation from the ground. So as soon as a crew member is ready to start their operation, they can walk right up to the robot workstation, and it's all set up and ready to go for them.
And I'm curious, it seems like this might have been something that could have been designed all along, but this was actually an upgrade done to specifically preserve some more crew time.
Yes, we're paving the way so they can do more science, better prepare for HTV, get the space station ready.
Do you have any sense of how much time that saves? Like, how much did that boot up take?
Basically, in the 2 weeks leading up to a free flyer, it saved over an hour and a half of time, which is a lot of crew time.
And so this was the first time that they've been able to use that?
Yes. And we'll be rolling this plan out for all other free flyers, so we'll get this crew time savings every time.
Sounds like a very valuable upgrade. You were also explaining to me that you're also an instructor, which is kind of unusual for flight controllers.
Yes, it's just my background started with instruction, which is how I'm so familiar with robots, since it is a crew training tool as well as a flight control tool. So it helps kind of segue into that nicely.
And can you tell us a little bit about your background that led you to NASA and being a robotics instructor?
I got my degree in physics from the University of Nevada, Reno, and I've always loved the space program. I always knew I would end up here. And robotics is a very interesting field, so it was an easy transition. Started off as an instructor, training the crew members all the way back with increment 19, all the way up till now, and then started on the flight control side with actually executing ops from the mission control.
I would think having that instructor perspective would really help from being as being a flight controller as well, especially interfacing with the crew or knowing how they were trained and being able to kind of relay to them for real-time ops.
It does really help when the crew is involved to have a better understanding, or at least a really good understanding of how they're thinking, and especially if you've trained this particular crew, you're very familiar with their habits and what they like to do and how they operate. Each person is different, so it helps.
And there's an instructor assigned to each crew? Is that how it works?
Yes.
I would imagine, or it seems like I've even heard a little bit, robotics is some of the more challenging training that astronauts go through.
It is, and especially since it's not something you deal with every day, it has to come up periodically. It can be intense.
Can you tell us a little bit about what kind of skills are required, or what are the challenging aspects of it?
It's a lot of hand-eye coordination. Basically, you have at the robotics workstation, we have 2 hand controllers, and you have to operate these 2 hand controllers simultaneously to control a very large robotic arm out in free space and make sure you're watching all your clearances and looking at all your camera views and out your window. It takes a lot of brain power.
Yeah, and doing 2 hand controllers simultaneously seems like that would be hard. I know it would be challenging for me.
Yes, and especially with things like HTV4, you really do need both of them.
Gotcha. Well, thank you so much, Megan, for joining us and explaining to us some of the behind-the-scenes upgrades that are going on that have helped the crew and the ground control team be successful with these activities.
No problem. Thanks for having me.
Thanks so much. This is Mission Control Houston. As we've mentioned, the HTV cargo operations have been the highlight of the last week's activity, and specifically over the weekend as the onboard crew worked with the ground control team as they docked the HTV cargo craft to the space station, as seen in this live view. The hatch is opened, and then last night the flight control team used the robotic arm to move some of the pallets, and that footage will replay for you here again from yesterday's robotic activities with the HTV cargo craft. Again, you're seeing a video from yesterday's activities with the robotic arm, using that to maneuver some of the hardware from the HTV cargo craft. All that activity has gone smoothly throughout the weekend on board. The crew now enjoying an off-duty day after several busy days of HTV activities. The HTV, which is shown here, is a Japanese cargo craft that had launched a little over a week ago on Saturday, August 3rd. It's now attached to the International Space Station. That cargo craft was bolted to the space station on Friday morning, and the hatches opened on Saturday. The crew worked the rest of that day, getting a good start on the unloading of more than 3 tons of cargo and supplies packed inside. Yesterday evening, the robotics flight controllers here at the Space Station Flight Control Room maneuvered the robotic arm to extract the exposed pallet of spare parts and experiments from that cargo craft. They then handed it off to the Japanese remote manipulator system, or robotic arm, for its ground commanding to install that onto the exposed facility on the Kibo module. That concludes that replay. Again, all of that activity going smoothly, and the U.S. Crew members having a day off today to make up for that extensive work throughout the weekend.